Right, so here is an example of a question, another question. We're still going through our Hess law, right? This is nice because it is from your a past paper. Let's see. This Hess law says in the presence of a catalyst, this is your 2024 paper, I guess. In the presence of a catalyst, ammonia reacts with oxygen to produce blah 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 blah. Here is the according to the following equation. So here we have been given the equation, okay, and we don't know the delta H, okay, we don't know. Use the following thermochemical equations. Remember, here we have our thermochemical equations because they'll give us the balanced reaction and the delta H to calculate the heat of reaction at constant pressure. So what you should know is that this delta H is always calculated at some given value, okay? We will be knowing the pressure. So yeah, that's why they've talked about constant pressure. Don't let that confuse you. So now, how do we get? So this is our target. This is the target equation, and that is what we are going to be using. Let's go and take the first species we have here is NH3. Now we go to these equations and see if NH3 is appearing once in only one equation. In the first one, it's not there. In the second one, it is there. In the third one, it's not. So that means we can start with NH3, right? So now we are going to be making our equations. We'll say our equation one. Our equation one, we're just going to be changing this guy, okay? Now, what do we know? Our NH3 should be a reactant. Here he is a product. So that we know we are going to flip. That's the first thing we know we're going to do. And then again, here we want 4 moles. Here we have 2. So we are going to double it. So we flip, then we double. So equation 1 now becomes 4NH3, then giving us, we flipped it. Now we are going to double everything. This is 4NH3. So this N2 becomes 2N2 gas plus 3H2 becomes 6H2 gas. And what we know is the delta H1 is going to be positive, double 2 times positive 91.8 kilojoules. Okay, we change it to positive, then we double it because we have doubled the NH3, right? Now, what is the next one? O2, right? O2, where do we have it? We have it here, we have it there, right? You can see that we have our O2 in the first one, and we have our O2 in the second one as well, in the third one as well, the last reaction. So the next thing that I see, what I'm going to do is I look at O2, I see, okay, he's appearing twice, so I don't know which one to use. I'm going to skip him for now. I'll go to the next one, which is NO. Now, how many times do I have NO? I have it in the first one. What about in the last one? I don't have it in the last one. So I can use NO. And now what should I do to pick this guy? I know I'm going to work with NO. Here it should be at the product side. In my target, he is at the product side. So here he should be at the product side. And he is. So I leave him. In my target, we have 4 moles. Here we have 2. So we should double. So that means we are going to write our equation 2 now. Our equation 2 is going to be, we are doubling this old one. So it's going to be 2N2 plus 2O2 gas. Okay, this is a gas again. Then to give us, instead of 2NO, it's now 4NO gas. Then because we have doubled from 2 to 4, we are going to double our delta H. We'll now have our delta H2 being equal to 2 times 180.6 kilojoules. Okay, you can be putting the solutions if you want. Now here we have our equation 3, just to cap it all off now. Here is our equation 3. What would we now have? Basically, I can now just then look at my O2, which I had skipped. Now, I know that I'm taking equation 3 from this last one here. Okay, now, how many O2s should I have in the target? 5. How many do I have so far? I have 2. So I need 3. So that means I'm going to make this be 3 O2s at the reactant side because those 5 are at the reactant. So that means this was 1. I should triple it. So it's going to be now everything tripled. 6H2 gas plus 3O2 gas to give me 6H2O gas. Then my delta H3 is going to be 3 times what I have, negative 483.7 kilojoules. because I needed 3 moles. Okay, if you're not sure, you can go and check the videos on Hess, see the videos again. Now, when it's like this, I can get my overall. The reason I was writing on the paper is lack of space, so you'll be writing on your answer sheet. Now, once I have it like this, I can get my overall, right? How do I put my overall? First, I put all the reactants. So I'm going to have 4NH3. What was NH3? It was a gas. So gas plus the other reactant is this one, 2N2 gas, plus the other reaction, 2O2 gas, plus here is the other reactant, hydrogen, so it'll be plus 6H2 gas, plus here is the other one, 3O2, so 3O2 gas. To give us, we have 2N2 gas plus 6H2 gas. The other one is NO, so plus 4NO gas, plus the other one is H2O, so 6H2O gas. Okay, there we go. So now first thing, we're going to cancel anything that is there on both sides. Ammonia, is it there on the other side? No. N2, is it there? Yes, so it's going. O2, we have 2O2 and then no, we don't have it on the other side. H2, yes, it's there, so we cancel. Then we remain with this. So basically now we can write to say 4NH3 gas plus 2 plus 3 becomes 5O2. Okay, 5O2 gas. This should give us 4NO gas plus 6H2O gas. Is this similar to what they want, to the target? Yes, it's the same. To give us 4NO plus 6H2O, yes, we have 4NH3 plus 5O2. They are the same. So basically now we know, and we have our delta H being equal to, you add all these three, right? We're going to say plus and plus and plus. So it's going to be, we'll say 2 times 91.8. If you want, you can say 2 by positive 91.8 kilojoules plus 2 by 180.6 kilojoules, then plus 3 by negative 483.7 kilojoules. Then we are going to get our delta H. So 2 open bracket 91.8 close plus 2 open bracket 180.6 close plus 3 open bracket negative 483.7 close. We'll get it as negative 906.3 kilojoules. Okay, there we have, and here is our delta H. So now we've been able to get our delta H, and if we write as a final, we would say 4NH3 gas plus 5O2 gas to give us 4NO gas plus 6H2O gas, and our delta H would be negative 906.3 kilojoules. This would give us the final solution, and you're done.